Verify that 2, 1, 3, 2 and 2, -1, -3, 2 are inverses. So what does it mean for two matrices to be inverses? What does it mean for one matrix to be an inverse for another? They need to multiply to make the identity. Okay? And one of the nice little sort of results that we observed in our lesson here is that you only need to multiply them together once in one way to verify that things are inverses. So let's take our two matrices, 2, 1, 3, 2, and what was it? 2, -1, -3, 2? I think that was it. Yes. So let's multiply them together. And we know how to multiply matrices, so it shouldn't be too bad for us. Okay. So what are we going to do? Well, first, dimensions. Okay. Got a 2 by 2 matrix here and a 2 by 2 matrix here. So, yeah, they can multiply. I mean, at this point, we've seen matrix multiplication so many times that we probably didn't really need to actually write those out. But if you do, then that's okay. So we make space for a 2 by 2 matrix. And then we say, okay, first row dotted with first column. So that's going to be 2 times 2 plus 1 times -3. So that's 4 minus 3. That's a 1. Okay. So now let's do first row, second column. 2 times -1 is -2. Plus 1 times 2 is going to be 2. So -2 plus 2 is going to be 0. This is looking great, but we can't just assume. We got to go through everything. Move down to the second row in the second column. 3 times 2 is 6. And 2 times -3 is -6. Add those together, we get 0. Okay. And then one last one to check. We hope it should be a 1. It should be a 1. Okay. 3, 2, dotted with -1, 2. So 3 times -1 is -3. 2 times 2 is 4. -3 plus 4 is 1. So yes, they are inverses. And this is how we check. Just multiply the two matrices together. So we could say something like 2, 1, 3, 2 inverse is 2 minus 1 minus 3, 2. Okay. We don't have to do that. We could say the first one was an inverse of the other because they both satisfy the definition. Okay. But yes, they are inverses, and this is how we show it.